Hi, it's Jan Beta, and today I have another Commodore 64 mainboard here that Adam donated, like the one I repaired in the previous video. So I thought it would be interesting to have a look at this as well in a separate video. The last one I repaired, it had the MT brand RAM chips. This one apparently has Oki chips, which are, I think, more reliable than the MT chips. This actually outputs scrambled video, as Adam wrote down on this board. And yeah, let's just, as in the previous video, if you haven't watched that, I recommend doing so. I'm going to link that in the corner there. As with the board in that video, this came without any of the custom MOS or later CSG chips, ICs. They were all socketed on this board, so they all got pulled and used somewhere else, hopefully to repair other boards and not to make money on eBay or something like that. So actually the first thing I noticed is that this keyboard connector is severely bent, so I'm going to have to bend these pins into the correct orientation before I do anything with this. I think I'm just going to pre-bend them so they don't short out. And then I think the best way to straighten those without any special tools is to just straighten them halfway and then connect a connector to it, so the connector is going to straighten the rest out. Yeah, it's not perfect, but at least they are not shorting out against each other or anything, so this should do for now. Let me connect the power supply and see if the voltages are alright. Let's see what we get. This should be 5 volts, which it roughly is. AC should be on the other one. It should be 11 or something. Yes. Okay. The voltage actually is a bit high because there's no chips populated here, so there's nothing to consume power. So I think there should be the 9 volt, the 6 volt or thereabouts, which is the voltage rail called 9 volts unregulated. That's around, yeah, close to 7 volts. Which I think is normal. It was the same on the other board and that worked. And then my voltage regulators should have the leftmost pin is the voltage input and the rightmost pin is the voltage output. So we should have 12 on this one, which we do, and we should have 5 on this one, which we do. And these are pretty much spot-on voltages because, yeah, these are linear regulators. They output very clean and very accurate voltages until they fail, which they sometimes do. That's why I'm measuring this. When they fail, they can actually fail in a way so that the input voltage, which is usually a lot higher, gets just passed through to the output. And yeah, damages everything connected to it. In this case, most of the times, which is in this case the VIC-II chip, which is the graphics chip, and the SID chip, which is of course the sound chip. By the way, this is another assembly number 250425, which is the second to last revision of the long C64 boards before they went with the shorter boards with less chips. And yeah, after this there was one more revision of the long board, which is the 250466, which is a very sought after board because it has some quirks that the others don't have. In particular, it has less RAM chips, so there's less to fail basically. They are usually the larger RAM chips. Smaller RAM chip count is a bit more stable than having 8 separate RAM chips. So check the voltages. This should be safe to put ICs in. First of all, I think I'm just going to spray some contact cleaner into the sockets again. Remove some of the more obvious dirt here. Yeah, let's try and clean this up a bit and spray some contact cleaner inside so we don't have any contact problems in these sockets, which there always might be. Actually seen that a lot. So if you get intermittent faults with C64s or any system with socketed chips, the sockets are always something to take into account as the possible cause of the fault. Oh, I'm using this Tesla Knoll, which is a bit more aggressive than the red Tesla Knoll, the Tesla Knoll Oscilline. I regularly use. This is a bit more aggressive and it's not recommended to use on like potentiometers and stuff, but it cleans. The cleaning is a bit more aggressive too, so that's good for a dirty board like this. Okay, let me take this couple of seconds to thank my sponsor for this video, which is PCBWay, a manufacturer of prototype PCBs, and also they offer more advanced PCB manufacturing processes that are really sophisticated. They also have excellent service, and if you need your own PCBs made, be it for prototyping or for something more advanced, in my opinion, they are very well worth checking out, so give them a try. In order to populate the board, I'll have to take the chips off the board we repaired in the last video, because I still don't have enough chips to populate like 2 Commodore 64 boards, even though there were quite some offers and quite some donations after I told you about my lack of MOS chips in the last video. So thank you very much to everybody who donated chips and boards. Okay, got all the ICs in. I'm leaving out the SID sound chip because I don't have a spare one and it is not necessary to run the system. You won't have sound this way, of course, and you won't be able to use a mouse or pedal controllers with this system, but this is about troubleshooting this, so it doesn't matter much for this purpose. Okay, let's see what this actually does if I turn it on and connect it to a monitor. I have it connected to the monitor now via my cheap upscaler that I'm also going to link in the corner of the video here. I made a whole video about that, how I put bullet holes in that cheap upscaler so it doesn't overheat. Let's see what it actually does. Does it do anything? Oh, look at that! It actually does work. Okay, that was kind of boring. It does work. Maybe it was just a matter of some shorted pins somewhere or a socket that didn't make good connection or something like that. Okay, I put my dead test cartridge in it for a start and let's see what it does actually. Turn it on. And the dead test famously takes quite some time to start up, so there we go. Let's see what these tests actually, if they show any defects. I guess maybe this just works and it was just a wonky VIC-II chip or something like that that was causing the scrambled screen. Yeah, I'm just going to leave this running for a while and see if it finds anything. So, apart from the sound, it just seems to pass the test fine. Okay, it's not fully working. I found this. Let's see if it does it again. I have Jupiter Lander on my dead test cartridge as well because it uses the same memory map mode basically. And as you can see, we have some scrambled screen going on there. I wonder if that happens in the basic screen as well. No, it doesn't. Okay. That's kind of a weird fault. The cartridge port feels a bit wonky actually, so maybe we should just clean that up for a bit. Yeah, that's a reproducible fault actually with the Jupiter Lander card. Yeah, kind of a strange one, I guess. Okay, I'm just tapping the chips a bit. There's something wrong. Could just be a capacitor issue or something. Maybe. Oh, I think it might just be a cartridge port issue. Did you see that when I wiggled the cartridge a tiny little bit? I'm going to clean the cartridge port quite thoroughly and see if that helps. Oh yeah, that's pretty dirty. Let's see if we can clean that up. It's always one of the things you want to do. If you basically can tell if a machine has been cleaned at some point, most of the times. So this looks okay. I guess there are no bent parts here. But still just might be wonky contacts on the cartridge port. I think I also want to resolder some of those joints here. So I don't know if you can see it, but some of these, I think probably from factory, look not 100% legit. So I'm just going to go around here and add some solder to each of these joints, so to be sure that the connections to the board are there. I think that might be the issue. There might also be a broken trace somewhere here, but at least I can't see any. So that actually is, I think, the first time I used the Jupiter Lander cartridge as a test cartridge, which was something the Commodore engineers did quite a bit in the factories too, because the DAT test, both the DAT test and the Jupiter Lander cartridge used the Ultimax cartridge mode, which is basically compatible with the Commodore Max or Max machine, which I did a separate video on. If you want to watch that, there's a bit of history in there of the predecessor machine, basically of the C64. And that had it had very little onboard RAM and it had no ROMs on board. So all the ROMs were on the cartridge. So what this Ultimax mode that is still present in the Commodore 64 for backwards compatibility with the Max cartridges, that mode basically replaces or overrides the ROMs in the Commodore 64 and puts what is on the ROM in the cartridge in place of the ROM. Yeah, so you can use the DAT test cartridges without any of the ROMs in the Commodore 64 working or present for that matter. And Jupiter Lander uses the same mode because it was a game that was initially planned, or it is the same version basically that was used for the Max machine. So that's why that is such a useful thing. Okay, let's redo some solder joints. For that purpose I'm just going to add some fresh solder. If you were to do it really properly, you would have to remove all the solder completely, clean up the area and add new solder, because sometimes the different kinds of solder don't mix. There is some flux residue from the factory, I believe, which is kind of normal. The connectors and stuff like that was, I think, hand soldered after the rest of the components were soldered on, so you get some flux residue on there because they didn't take the time to clean it up. And I mean, that's okay, it lasted, still lasted a couple of decades. And the board seems to be mostly okay. kind of an intermittent fault, so yeah. Hope this fixes it. I kind of love working on C64s. So hopefully you are not bored by watching me fix or trying to fix Commodore 64s. Yeah, I kind of never get bored by these. So, okay, clean that up a bit. It also might be that the whole connector, the plastic seems a bit bent, but we're going to see. We're going to see if this works out. Maybe that was enough to fix this thing. Let's see. Nope. Okay, I'm holding the cartridge in. Yeah. Okay, there's definitely something wrong there. Doesn't make good contact. That's a wonky cartridge port. So I'm just going to take one of, like a pokey thing, whatever, like a needle or something, and just bend these a bit. So they make, maybe, hopefully make better contact with the edge connector. Or the PCB edge. This is the edge connector, actually. They make better contact with the PCB edge in the cartridge. So maybe that fixes it. Bending these up a little bit. So, okay, let's see. Let's put this in. Okay, some more contact cleaner. Also going to give this area on top here a good cleaning. Because it seems to be pretty dirty. I wonder, maybe there's some... Might be dirty to an extent that there's some current flowing between the pins or something. The traces seem alright, actually. At least from the visual inspection. Just watch this area a bit closer too, from the top and the bottom. Traces seem to be alright. Nope. Okay, but the contacts seem to be better. So if I'm wiggling the contacts, the fault is at least consistently there. So we fixed the wonky contacts on the cartridge port, which isn't a bad thing. We still have the scrambled screen problem. So I fiddled around with this a bit. I'm going to try some other things, some different things here. I had some graphical corruption, but it's nearly impossible to reproduce any of those faults. I had the characters, like these were like little hyphens, and the characters were like shifted a couple of characters. So like it was using the next character in the list of characters in place of the character it actually should display. So there's something wrong. There we go. And this happens after like a while. That's quite interesting, actually. It's also saying VIC. Yeah. So there's definitely some kind of intermittent thing happening as soon as this warms up a bit. I would suspect, as I'm hitting the board and nothing changes, basically. So that's always worth a try if you have intermittent faults, to determine if it's actually something to do with something don't making good connection or anything like that. Just slightly tap the chips and the board. In this case, it doesn't seem to have anything to do with the bad connection. Yeah, really interesting. Interesting fault. So now with the 1541 Ultimate disconnected, it does the exact same thing, so it wasn't due to the cartridge. This is the exact same screen we saw before. Some bytes for the characters seem to be shifted around. The Y is a Q, the O is a G, the E, the M is an E. Yeah, it's really interesting. So unfortunately, it even got worse with the Jupiter Lander card now. And this is something that can be caused by a broken VIC-II chip. Apparently also the shifted characters can be caused by a broken VIC-II graphics chip. I think what I'm going to do is to take this chip out, which is a beautiful 1983 old MOS ceramic VIC-II chip, which would be a bummer if this wasn't working, but it would also be not a surprise because this is an old IC. The fault also is it's kind of intermittent, so we don't get it on every power-up, and we also sometimes get it after a while, after warming up. So it might be caused by this chip. I'm going to try to clean this whole area up because there's quite some dirt. Actually going to clean the whole board, I guess. But I suspect maybe it's just my VIC-II that's broken that I put in there. So I think I actually have another VIC-II that I can try somewhere. So let me remove the chip. By the way, I'm going to link this chip puller, which is like it's an invaluable tool for safely removing ICs to me. I'm going to link that in the description in case you want your own. There was quite some dirt underneath there as well. Maybe that didn't help. This board is quite dirty, but it's nothing. Doesn't look like it's dirty to an extent that would short out pins or anything like that. So yeah, it didn't hurt to clean it thoroughly, I guess. So what I'm going to do is to put the other VIC-II chip that I hopefully can find in here and see if that changes the behavior, because I strongly suspect that it has something to do with the VIC-II. By the way, I checked the voltages going to this socket and they are correct, so I'm not worried about the IC being damaged too much. So this is one from 1984, according to the date code. Not quite as beautiful. Let's see what that says. So I kind of suspect that it's just the VIC-II. Let's see if it works with this one actually. Okay, this doesn't do anything. Why is that? Huh? What did I do to break this? What? What's going on? I think the power supply is probably, I don't know. There's no 9 volts coming through, okay. So now we have the situation that our 5 volts supply is here. That's the one coming from the power supply. Don't know if you can see that very well, but just trust me. And the AC, the 9 volts AC, which is 11 volts or something thereabouts in our case, is not coming through. That means that the voltage regulators are also not working correctly. They won't produce anything, basically, probably. No. Because there's no voltage coming in. Like 0.6 volts coming in into them. 1 volt. Yeah. So maybe there's also as good as no voltage on the capacitors here. Which leads me to believe that there's something wrong with the power supply. Like the supply to the board. I don't think there's something wrong with my power supply that I made. Let's see if the fuse is good. I've set this to continuity testing. The fuse is basically the 9 volts AC fuse. Yeah, that's good. Let's see. It actually comes through the circuit board. Yes. Yeah. Maybe the power switch is a bit wonky, intermittent. That tends to happen on these. Let's figure that out. Okay, I have this plugged in and set it to DC. Should set it to AC to see. There's my AC voltage, and it's coming from the power supply. Okay, let's get a bit further into the circuit. To our bridge rectifier, which is, I've marked it from the back side to make it more convenient. We should have our AC going in here. Let's switch this on and see if the AC actually comes through to the rectifier. This should be our 10 volts. Yeah, that's our AC that's coming directly from the power supply. We should have some AC left. It should measure some AC here, but not as much. Yeah, should have other way around, minus and plus. We should have a higher voltage here. DC voltage, which actually is the rectified voltage, 12 volts. That's nice. Okay. So it comes through to the rectifier. So next step would be the smoothing capacitors, actually, these large capacitors here. I think actually this one should be connected directly to the voltage. Yeah, we have 16 volts DC there, no worries. We have 12 volt DC there. We have 23 volts DC here. Okay. Oh, now we have voltages again from the voltage regulators. So maybe that's an intermittent fault with the power switch, which is quite common actually. Okay, so the good news is after spraying some contact cleaner into the power switch, it seems to work better. Yeah, I had the same fault with the different VIC-II chip in there, so it's not the VIC-II chip. So here's what I think. It's definitely not the VIC-II. It might be some traces around the VIC-II area, so I'm going to re-solder all the solder joints there and see if that helps with the fault. It seems to be stable now. I don't know if that's... It's always kind of difficult if the fault doesn't happen all the time. It might just be a power issue. The power switch was definitely wonky. And I just sprayed some contact cleaner in there from the outside, which usually helps making it temporarily work at least. Yeah, it might still be wonky. The power switch basically switches the 5 volts and the 9 volts, and both need to be present for the system to work in case of the older long board C64s. Because the VIC-II needs the 12 volts that are derived from the 9 volts AC. So if you get a blank screen like I had with no video sync at all. It might very well be the fuse, because that provides the 9 volts AC to the rest of the board. Oh, look at that. Okay, our fault is back. So that's our fault again. And I don't know if it changes or anything, if I touch anything close to here, or if that was just a coincidence. Seems to be pretty stable now. So I'm just resoldering all the connections on the VIC-II itself. These are really sturdy chips generally, and if they fail, they only fail gradually. I think these both VIC-IIs are okay actually, because we have the same fault with both. So it's gonna be some kind of connection issue, or the other idea I have, it might also be a logic issue. And I in particularly have one IC that might be a suspect in that regard. So I'm also going to put some new solder into all these little vias here, because it might just be like an intermittent grounding problem or something like that. These chips can behave in weird ways, and the board is pretty old. It's also one of the crinkly ones where they added more solder basically to make the traces wider, and then they added the solder mask, and then added the solder for the components actually. This is like the ground plane got some extra solder basically on these. Yeah, also adding some here because that's the power switch. I'm adding some solder to that too because it looks rather dirty. I wouldn't say it looks necessarily looks as if there's no good contact, but still can still be a lot of things obviously. Let's try that again, shall we? Okay, we have a picture again at least. Just flexing the board slightly. Kind of seems better. Jupiter. No, still the same issues with Jupiter Lander. That's strange really. What a strange fault. Particularly strange that it happens with the cartridge and it doesn't happen in BASIC. And we get a different fault in BASIC basically. Basically. I think there was a wonky connection here. Let's just leave this running for some time. Yeah, I'm inclined to just leave this running for a while and see if that changes again, or if we at least fix that fault, which I believe might have been caused by a wonky connection here. Yeah, I'm just going to leave this on for some time and see if it changes behavior. So I had this running for some time and actually put a nano swin sit in there to just have something to produce sound. Not the best option obviously, but yeah, it is back to the fault where it just prints the wrong letters on screen. A lot of stuff works, but there seem to be graphical glitches of some different kinds, including this one. There's some wonkiness going on here. Maybe I'm just going to replace the sockets here anyway and see if that helps. The 8701 chip, which is the main clock generator chip, which is this one, which basically replaces the discrete or more discrete logic chips. They are integrated chips, of course, ICs, that were present in previous versions of these boards. These are prone to failure, actually. They are not very reliable, at least some of them. And they usually produce a black screen because you don't get a sync signal. So if I touch the pins on this, it produces some weird issues. Of course, because the sync gets all messed up. But also I think what happens is that the fault changes that we had. So maybe it's kind of a timing issue. The shifted letters, though, seem to be also a symptom if one of the logic chips fails. In particular, this U14, which is 74 LS258, I think, yes. And these normally cause like 2 blinking cursors and stuff. They can also cause the letters to be shifted around. So maybe that's the case here too. Still, the fault only occurs every now and then, so I don't really know how to reproduce that. So it doesn't really seem to have anything to do with heat or anything like that necessarily. I'm just going to try stuff out some more and see what we get. I think that's actually the NTSC version, so the music runs faster now in this PAL C64. Yeah, it seems to work for the most part, but it has like this intermittent fault of the letters being switched around and some graphics not working correctly. I'm kind of suspecting U14, the logic chip I mentioned, to be kind of wonky. Or there's still some more issues around the VIC-II. Really, really interesting fault. I haven't seen anything like that. And it's also intermittent, so it's really difficult to troubleshoot this. I would think that maybe it is our little logic chip here that doesn't work correctly. So fiddled around with this a bit and played some games actually, and they all worked fine. And then we were back to this, the exact same screen, and I think I have it pretty consistently showing this screen now. It was good for quite a while, for an hour or something like that, and now it's back to the scrambled letters. I tried replacing this MOS7701 chip, which is the master clock chip for the VIC-II chip that makes the signal from the crystal interpretable by the VIC-II, basically. It amplifies the signal and delivers it in a clean manner to the VIC-II. That is good. Swapped it with a known working one, and that didn't change anything. Basically, we now have this Kijid Balzac all the time. So I think what I want to try next is to replace the 74 Logic chip, the chip located at U14, and see if that changes anything. By the way, I have put some soldering tips and desoldering tips in particular in the previous video, so I'm not going to talk about that in depth again. Using my desoldering station to desolder U14, which is 74258 logic chip. Just realized I don't have a 74258 in stock, but I have this other spares board that was also donated by Adam. Thank you so much. That has U14 still populated. This is the slightly older version 250407 board revision, which has all the... they are not populated, but there are a couple of logic chips that were replaced with the 8701 clock generator chip. This was... in former times there were more chips around the VIC-II chip that did the same job, basically. This has the same 74LS258BN in here. I believe you can use several different varieties of the 74LS258, but not all of them work equally as well, I think. And this, as you can see, this has been patched up. It has some trace damage and things like that. So it also has the MT RAM chips I've just seen that we've seen in one of the last videos. Yeah, basically there's a lot of bad MT RAM chips. I'm just going to pull this chip here because this is a parts donor. And that's what it's for. There we go. Okay, got myself an equivalent chip. Just going to straighten the legs a bit. These have been cut off, so it's not that trivial to have these sit in a socket tightly, but yeah, usually you can get it done if they are not too short. Seen some Amigas where that was really difficult to do with some of these solder chips, but this particular one seems to be fine. If I can get it in the socket. There we go. Yeah, this sits really tightly. Okay, let's see if this actually works and if it fixed our problem. Nope, didn't fix our problem at all. Okay, back to square one. So cleaned up the whole area again, put some contact cleaner, resoldered most of the vias in this area and cleaned up the board. And now, for the moment at least, it's back to good. No idea how long this lasts, but we're going to try. I'm just going to play some Commodore 64. There's definitely worse. And I'm going to see if I can reproduce the fault again, or if that fixed it. So after poking around for a bit more, the fault is still kind of intermittent. Read up on some forums, and some people said that the shifting of the characters, like shifting to another character, may be caused by this 74LS373 chip as well. And watch what happens if I touch it a bit. U26 is the chip, the LS373, 74LS373, of course. We're getting a similar effect to what we saw with Jupiter Lander. So this might just be the culprit. Might also be that some of the traces are bad, of course. I just crashed it by touching a trace there. Whoa, okay. What's going on now? So I looked up U26, and what it does is that it basically is an interface for the VIC-II to address the color RAM and the character ROM. So this might be our culprit here. Because if this doesn't work, it is very possible that characters are addressed incorrectly. So yeah, I'm just going to change that. I think I have 74 LS373N chips in stock. I'm just going to put a new one in and see if that fixes our problem. Hopefully. Yeah, kind of a messy troubleshooting process, but maybe we are going to get there. So I found a brand new Texas Instruments 74 LS373N, which is the same. It's actually, this is also a TI chip, it seems. Okay, so that's a modern made one. This is an old one. I'm out of sockets, unfortunately, so I have to improvise a bit and make a socket, more or less. Just going to use parts. So I'm just going to put this in and then I put another part of this socket in, I guess. Okay, doesn't look too bad for a DIY kind of socket. Let's put the new IC in. Brand new 74 Logic. And here's another trick I use. You can just put it on a table or a flat surface and bend the pins slightly inwards so it fits better into the socket. There we go. It should be in there. Okay, maybe, hopefully, that fixes our problem. Just realized one leg didn't make it into the socket. This stuff happens, so if you're repairing something and don't pay attention, you easily miss one of those and yeah, scratch your head for the rest of the day and don't know. Okay, let's try. Okay, fingers crossed this is going to work. Yes! Okay, at least we have the correct picture for now. This looks kind of promising after replacing this chip. And it would make sense as the cause of the fault. As I said, it interfaces the VIC-II to the color RAM and the character ROM. Yeah, now let's try this machine for some more time and see if this actually fixes the fault. I hope so. Okay, here's something that gives me a lot of hope for this machine. Look at that. I have my dead test / JupyterLearner cartridge in and it doesn't do the flickering thing. So it might just be fixed. It looks good. Yay! So I was playing for a little bit and this seems to have fixed it. So it probably was the logic chip we replaced last that was causing the issues altogether. I think there's still some wonky traces and some intermittent stuff that I was unable to find. But it sometimes crashes randomly, so there is, maybe it's just a matter of replacing the capacitors, which I'm eventually going to do. Could be, because it's so intermittent. There are some random crashes sometimes, but overall this was what caused the issue in the first place. So I consider this at least an interesting fault that I've never seen anywhere else, actually, in this kind of manner. Yeah, I hope this was informative. Thanks so much for watching. Thanks for supporting me if you are a supporter. Thank you so very much. If you are not a supporter yet, maybe consider supporting me if you find this stuff interesting. More to come, lots more to come about the Commodore 64 and also some other systems. So stay tuned for more. Thanks for watching. I'm Jan Beta. See you next time. Bye. Okay, this time for real. Idiot.